Hi everyone, thank you for joining. So in this video we're going to solve an interesting integer equation. This was a question in Romanian mathematical Olympiads. So the question says, given that x, y and z are positive integers, so they are not only integers but they are positive integers, find the values of x, y and z, right? So if you like to pause the video here and try it yourself first, then we could go over it together. Right, so the first solution is quite obvious. If we have x, y, z, we can simply guess the first solution is 5, 5, 5, isn't it? Because you have 1 over 5 plus 1 over 5 plus 1 over 5 will give you 3 over 5. But of course, it's good to have an intuition, yeah. But also we need a method that will give us all the answers rather than answers only, right? So how can we solve this question then? One way to go ahead is the exploit a nature of real numbers, as we know that real numbers can be ordered. In other words, one is less than the other and so on. So we can, without loss of generality, we can say let x be less than or equal to y, less than or equal to z, right? So we've ordered them, right? Notice that we couldn't do this if, of course, x, y, z were complex numbers. As you'd agree, 2 plus I is less than 1000 plus 200i. This would be a meaningless statement unless we're considering the magnitudes, right? So with real numbers, we can order it. Now, right, what do we do here? Now, we need to find the lower limit. So if we think about it, the lower limit will have to be 2. Why is that? Because if x is less than 2, let's say x is 1, right? Then what we have here is we already have 1 there, and there is no way by adding something, positive quantities, because x, y, z are positive, by adding positive quantities 1 to 1, you're not going to get 3 over 5, something less than 1, okay? So, all right, so what we can do now that we have this inequality, we can write instead of 1 over x, 1 over y, 1 over z, we can just replace all y and z by x. Well, that will give us 3 over x. That will mean it will be greater than or equal to 3 over 5, isn't it? I'm using this combined with that, since x is less than y is less than z, as x is the smallest number, and then 3 over x will have to be greater than or equal to 3 over 5, right? Okay. Now, looking at this inequality here, so we know that x must be an element of the set, which consists of 2, 3, 4, and 5. Okay, it can't be bigger than 5, otherwise it would violate this inequality here. Right, so we know that x's belong to this set now. We can simply test these numbers. So if we let x to be 2, the equation 1 over x plus 1 over y plus 1 over z is equal to 3 over 5 becomes 1 over y plus 1 over z is equal to 1 over 10. That is 3 over 5, take away 2, right? If we start playing around with this, let's make z the subject. So we have 1 over z is equal to 1 over 10 minus 1 over y, which is equal to y minus 10 over 10y. So that implies z is equal to 10y over y minus 10, right? And we can rewrite this actually as 10 plus 100 over y minus 10, isn't it? If you cross multiply, you will see that it will give us the same expression. Now, we know something about z, that z is an integer, and it's not only an integer, but it's a positive integer. That means this quantity, well, we know 10 is already an integer, so this has to be an element of positive integers, right? Or it doesn't have to be positive integer. We could say it will just be an integer such that z will be an integer, right? So, okay, so now there are so many numbers we can try from 0 to 100, 1 to 100, because y is a positive integer. But let's notice that y will have to be element of, first of all, lower limit of the y will have to be 10. Why is that? Because if you look at this equation, it has to be 11, not 10, because if y is equal to 10, you already have 1 over 10 is equal to 1 over n. So this has to be 0. But z is a positive integer, and 1 divided by a positive integer will not give you 0. Therefore, y can only be 11, or it could be 12, all the way up to 20. Now, y will have the upper limit as 20, and where does that come from? Well, if you think about it, looking at this, combining with the initial statement, we had this, didn't we? So let's get rid of x from here because it's not relevant. So if y is 20, so we have 1 over 20. That means z will have to be bigger than y, so minimum value, or bigger than or equal to, less than or equal to, minimum value z can take is 1 over 20, so z is also 20, which gives us 2 over 20, which is 1 over 10. So we already hit the limit, right? So if y is bigger than 20, that means z will have to be, let's say if y is 21, z will have to be 21, or something bigger than 21, and it is impossible to get 1 over 10 on the other side. So this is the limit. This is the set the y belongs to. All right. Now, why is that important? Well, it's important because it will reduce the number of trials that we have to do, right? Okay. So based on this now, since y can be anywhere between 11 to 20, let's have a look at 100 over y minus 10. So, and we want this to be an integer, right? So element of integers. So what have we got then? Well, y could be 11, 100 over 1. Yeah, so y could be 11, that would work. Y could be 12, yeah, 12 would work as well. It can't be 13, it will be 14, or 15, or 20, isn't it? Because we will then have 100 over 1, 100 over 2, 100 over 4, 100 over 5, and 100 over 10. And this will all give us a integers, so z will be an integer, right? So now we know that. We know the value of x is 2, so let's write it down. So we have 2, 11, and we don't know what the z value is. 2, 12. Okay, so these are all the possible answers, and all we have to do now is find the values of z simply by substituting these values into this equation here. So let's rewrite the equation here. So we have 10 plus 100 minus 100 over y minus 10. So when y is 11, we have 10 plus 100, so it will give us 110. Okay, so for x is equal to 2, this is the solution set we have, right? So the next task here is to try to use the same method for x is equal to 3, x is equal to 4, but I will do x is equal to 5 because we will see that if x is equal to 5, we will have 1 over y plus 1 over z is equal to 1 over 3 over 5, apologies, 3 over 5 minus 1 over 5, which is equal to 2 over 5. That implies 1 over y plus 1 over z is equal to 2 over 5. Well, simply y is equal to z is equal to 5. So this is the solution we've guessed to begin with. So x is 5, y is 5, and z is 5. So what I'll do is that I'm going to write the answers for these two cases, and you can try it to proving it yourself using the same method. If you don't get the right answer and so on, please write it in the comments that I'll respond to that. Okay, so these are the solutions for x is equal to 2, x is equal to 3 and 4. Right, okay. Well, I hope you found it interesting. I hope you enjoyed it. Thank you so much for joining, and I hope to see you in my future videos. Thank you.